Hello, in this lecture we'll find out the radius of a circle. In the drawing we have a circle. Inside the circle we have chord dB. The length of chord dB is 2 units. We have also here chord AC. Chord AC equals to the square root of 2 units in its length. This is angle DAB. And angle DAB equals to 45 degrees in its size. Again, our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. By joining points A and D, we can deduce peripheral angle BAD. This is peripheral angle BAD. We define the size of this peripheral angle BAD as x over 2. And this peripheral angle BAD is substance on chord dB. Repeat again, peripheral angle DAB is substance on chord dB. In the next step, we'll define the center of this circle, this point O. And we will join points O and D together by a straight line. We will join points O and B together by a straight line. By doing this construction, we can do center angle DOB. This is center angle DOB, and this center angle DOB substance on chord DB. So we have here those two angles, the above substance on the same chord called DB. So now we can implement Rule 13 in our drawing. So I repeat quickly on Rule 13. According to Rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB subtends on chord AB. In addition, we have here center angle AOB, and this center angle AOB is also subtends on chord AB. So those two angles, they are both subtend on the same chord called AB. And therefore, the size of this center angle AOB will be twice as large is the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, therefore the size of this center angle AOB is also subtended on the same chord called AB will be equal to 2 theta. So we can actually implement Rule 13 in our drawing. Why? Because in our drawing we have those two angles, the above subtend on the same chord called DB. The size of this peripheral angle DAB is x over 2, and therefore according to Rule 13, the size of this center angle OB that is also subtend on the same chord called dB will be equal to x over 2 times 2, that is x. Likewise, we will define the size of peripheral angle ADC. This angle, peripheral angle ADC, as y over 2. So this peripheral angle ADC subtends on chord AC. In the next step, we will join points O and C together by a straight line. And we will join points O and A together by a straight line. By doing this construction, we can deduce center angle AOC. This is center angle AOC, and this center angle AOC subtends on chord AC. Exactly like this peripheral angle ADC, it is also subtends on the same chord called AC. Now we can implement rule 13. According to rule 13, the size of this center angle AOC that subtends on chord AC, like this peripheral angle ADC that is also subtends on the same chord called AC. The size of this center angle AOC must be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of this center angle AOC is also subtended on the same chord called AC must be equal to y over 2 times 2, that is y. According to rule 13, of course. In the next step, I'll copy the green triangle ADE, this green triangle ADE, in the new page, and we will implement rule 4 on this triangle ADE. So actually, this is triangle AED that I copied from the original drawing. Inside this triangle AED, we have those two angles, x over 2 and y over 2, and this is also angle AED that is located inside this triangle AED. So all those three angles are located inside this triangle AED, and therefore they are defined as the interior angles of this triangle AED. So I write it down. So all therefore those triangles are defined as the interior angles of this triangle, triangle AED. While this is angle BED, and this angle BED is located outside this triangle AD, and therefore it is defined as the exterior angle of this triangle, triangle AD. So this is angle BED, and it is defined as the exterior angle of this triangle, triangle AED. So in the next step, I'll present to you rule 4, and we'll implement rule 4 in this triangle, triangle AED. According to rule 4, the exterior angle of a triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing we have this triangle. Inside this triangle we have those three angles A, B and C. They are all located inside this triangle, and therefore they are defined as the interior angles of this triangle. While this is angle E that is located outside this triangle, and therefore it is defined as the exterior angle of this triangle. According to this rule 4, the size of the interior angle E is equals to the sum of the two interior angles that are not adjacent to it. This is angle C that is definitely adjacent to angle E. The two other angles that are not adjacent to this angle E, are those two angles, A and B. And according to this rule 4, the size of the exterior angle E, it is equals to the sum of the two interior angles that are not adjacent to it. That is to say, the size of angle E is equals to A plus B, because A and B are the two interior angles that are not adjacent to angle E. So the size of the exterior angle E is equals to A plus B, according to this rule 4. So you can actually implement rule 4 in our drawing. Why? Because in our drawing, this is the exterior angle, angle BED is the exterior angle of this triangle, triangle AED. And according to rule 4, the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle AED that is definitely adjacent to this angle BED. And the two other angles that are not adjacent to this angle BED are those two angles, x over 2 and y over 2. And therefore, according to rule 4, the size of the exterior angle BED will be equal to x over 2 plus y over 2. So I write it down. So we actually found out that according to rule 4, the size of the exterior angle BED is equals to x over 2 plus y over 2. But it is given as an equation that the exterior angle BED equals to 45 degrees in its size. So we can substitute angle BED by 45 degrees, and we get that 45 degrees equals to x over 2 plus y over 2. So here we will multiply this equation by 2. And finally we get that 45 degrees times 2 is 90 degrees, so 90 degrees equals to x over 2 times 2 is x, and y over 2 times 2 is y. So in conclusion, we found out that x plus y equals to 90 degrees. So here we subtract x from this equation, and finally we get that y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. In the next step, I'll I repeat quickly on the law of cosines, and we will implement the law of cosines on those two triangles, triangle BOD and triangle AOC, those two triangles. But before that, what is the definition of line segment OB? Line segment OB starts from point O, that is the center of the circle, and that's at point B, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of this circle. We define the radius of this circle as R, therefore OB equals to R. This is the radius of this circle, the radius of the circle, the radius of this circle is the radius that we are looking for in this question. Likewise, OD will be also equal to R, OC will be equal to R, and finally OA also equals to R. It is also the radius of this circle. So in the next step, I will present to you the law of cosines. I will repeat on the law of cosines, and we will implement the law of cosines in this triangle, triangle BOD. So, first of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. In this triangle ABC, the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC. The size of this angle BAC is theta. And according to this law, the law of cosines, in this triangle, triangle ABC, that could be any triangle, the following equation will be true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta in this triangle ABC equals to A squared plus B squared minus C squared over 2 times A times B. In the next step, I will copy this triangle, triangle BOD in the new page, and we will implement the law of cosines in this triangle, triangle BOD. So actually, this is triangle BOD that I copied from the original drawing. So, in this triangle, triangle BOD, according to the law of cosines, cosine x equals to OD squared plus OB squared minus DB squared over 2 times OD times OB. So, I write it down. Repeat again, according to the law of cosines, in this triangle, triangle DOB, cosine x equals to OD squared. OD is R, therefore OD squared is R squared plus OB squared. OB is also R, therefore OB squared is R squared minus dB squared. dB is 2, and therefore dB squared is 2 squared, that is 4. So it is minus 4 divided by 2 times OB, 2 times OD, that is R, times OB, this is also R. So in conclusion, we shall find out that according to the law of cosines in this triangle ODB, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. R squared plus r squared is 2r squared, so in total, in the numerator of this expression, we have 2r squared minus 4 divided by 2 times r, that is 2r squared. So we found out that according to equation 1, cosine x equals to 2r squared minus 4 over 2r squared. 2r squared over 2r squared is 1. And we have also here minus 4 over 2r squared. So cosine x equals to minus 4 over 2r squared. So cosine x equals to 1. And here we divide both the numerator and the denominator of this expression by 2. And you get that minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we shall find out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Okay. In the next step, I'll copy this triangle AOC in the new page, and we'll implement the law of cosines in this triangle AOC. So actually, this is triangle AOC that I call it from the original drawing. The next step, we implement the law of cosines in this triangle AOC. So according to the law of cosines, in this triangle AOC, cosine y equals to AO squared. AO is R, therefore AO squared is R squared, plus OC squared. OC is also R, therefore OC squared is R squared, minus AC squared. AC is square root of 2, therefore AC squared is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times OA, that is R, times OC, that is also R. So cosine y equals to R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 2, divided by 2 times R, that is 2R squared. So here we have 2R squared minus 2R squared is 1, and we have also here minus 2 over 2R squared. So cosine y, according to equation 2, equals to 1, and we have here minus 2 over 2R squared. Here we'll divide both the numerator and the denominator of this expression by 2. And you get that minus 2 over 2 is minus 1, and 2R squared over 2 is R squared. So in conclusion, we shall find out that according to equation 2, cosine y equals to 1 minus 1 over R squared. But we have already found out in the beginning of the lecture that y equals to 90 degrees minus x. So I write it here that we already found out that y equals to 90 degrees minus x. So now we can substitute y in this equation 2 by 90 degrees minus x. We do it now, and we get that cosine y, and y is 90 degrees minus x. So it will be cosine 90 degrees minus x equals to 1 minus 1 over R squared. And again, if we found out that cosine 90 degrees minus x equals to 1 minus 1 over R squared. So we have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, you can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We do it now, and we get that according to equation 2, we have here cosine 90 degrees minus x, and according to this trigonometric identity, cosine 90 degrees minus x is sinus x. So here it will be sinus x, and sinus x equals to 1 minus 1 over R squared. This is according to equation 2. Well, according to equation 1, we found out actually that cosine x equals to 1 minus 2 over R squared. So we actually have the values of sinus x and cosine x in terms of R. R is the radius of the circle, that is the radius that we are looking for. The radius of this circle. So in the next step, we use the following trigonometric identity states that sinus square x plus cosine square x equals to 1. So we know that according to equation 2, sinus x equals to 1 minus 1 over 1 minus 1 over r square. If sinus x equals to 1 minus 1 over r square, it means that sinus square x will be equal to 1 minus 1 over r squared squared. Okay, so sinus square x equals to 1 minus 1 over r squared squared. And we have also plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared squared. And sine square x plus cosine square x equals to 1. So it will be equal to 1. According to this trigonometric identity, this will be equation 3. In the next step, we will define that t equals to 1 over r squared. So now we can substitute 1 over r squared in this equation 3 by t. We do it now, we get that according to equation 3, we have here 1 minus 1 over r squared. So it is 1 minus 1 over r squared. 1 over r squared is t. Therefore, we substitute 1 over r squared in this equation 3 by t. So in total, this expression will be equal to 1 minus t squared, and we have also plus 1 minus 2 over r squared. Here we'll multiply this expression by 1. Actually, it is allowable to multiply any expression by 1, because by multiplying the expression by 1, we will not change the value of the expression. So here we have 1 minus 2 times 1 over r squared. 1 over r squared is t. So in total, this expression will be equal to 1 minus 2t squared equals to 1. So actually found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. So here we'll open the brackets on this side of this equation 3. If I get that, according to this equation 3, we have 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. And we have also 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t, that is minus 4t equals to 1. So here we have 1 on both sides of this equation, so 1 will get cancelled. After we cancelled 1, in this side of equation 3 we have t squared plus 4t squared is 5t squared. And we have also minus 2t minus 4t is minus 6t, plus 1 equals to 0. So repeat again, we actually found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. And the only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value or the values of t, because x equals to t. So we'll do it now, and we get that here x equals to t, so we'll substitute x by t, and it is equals to minus b. b equals to minus 6, therefore minus b is equals to minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So we actually found out that t equals to 6 plus minus, inside the root we have 36 minus 20, that is 16 divided by 10. So we actually found out that t equals to 6 plus minus, the square root of 16 is 4 divided by 10. Repeat again. Okay. Found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So we actually found out that t equals to 1. So the first solution for t is that t equals to 1. From one side, but from the other side, according to our definition, t is also equals to 1 over r squared. And therefore, we can substitute t in this equation by 1 over r squared. We'll do it now. We'll get that 1 over r squared equals to 1. Here we'll multiply this equation by r squared. And finally, we get that r squared equals to 1. So here we take a root out of this equation, and finally we get that the radius r is equals to the square root of 1, that is 1. So we actually found out that the radius r of this circle equals to 1 unit in its length. But it is actually impossible that the radius r of this circle will be equal to 1. Why? Because of the fact that this gives us the equation that called db equals to 2 units in its length. Called db equals to 2 units in its length. And from the drawing, it is very easy to see that chord DB is definitely not the diameter of the circle. Again, chord DB is not the diameter of the circle. So I write it down. From the drawing, it is very easy to see that chord DB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course equals to 2r. So the diameter of 2r of our circle is the longest chord in the circle, and therefore it is definitely greater than dB, that is not the diameter of the circle, and dB equals to 2. And from this equation, 2r is greater than dB, that is equals to 2, we will derive that 2r is greater than 2. 2r is greater than 2. We will divide this inequality by 2, and finally we get that r is greater than 1. So we found out that the radius r of this circle must be greater than 1. If the radius r of this circle must be greater than 1, the radius r cannot be equal to 1. So the solution that r equals to 1 is the incorrect solution, because the radius r of this circle must be greater than 1. So we cancel the solution, and we take into account only the second solution for t. And the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So if we found out that the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t is also equals to 1 over r squared. And therefore we can substitute t in this equation by 1 over r squared. We do it now, and we get that 1 over r squared equals to 1/5. Here we cross multiply this equation, and finally we get that r squared equals to 5. R squared equals to 5. Here we'll take a root out of this equation, and finally we get that the radius r of this circle, that is the radius that we are looking for in this question, the radius r equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. And that is the answer to the question. I repeat again, we actually found out that the radius r of this circle equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing we have a circle. Inside this circle we have chord DB, that is equals to 2 units in itself. Chord AC equals to the square root of 2 units in itself. This is angle DEB. The size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So first of all, we join points A and D together by straight line. By joining points A and D, we can deduce peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle DAB is x over 2. And we know that peripheral angle DAB subtends on chord DB. Again, peripheral angle DAB subtends on chord DB. We define the center of this circle. This point is point O. Then we join points O and B together by a straight line, and we join points O and B together by a straight line. We join points O and B together by a straight line. When doing this construction, we can do straight triangle DOB. This is straight triangle DOB, and this straight triangle DOB subtends on chord DB. Exactly like this peripheral angle DB, that is also subtend on the same chord called DB. So those two angles, they are both subtend on the same chord called DB. Therefore, we can implement here all 13. So I repeat quickly on all 13. According to all 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the morning we have a circle, inside this circle we have peripheral angle ACB. This is peripheral angle ACB, and the size of this peripheral angle ACB is theta, and this peripheral angle ACB subtends on chord AB. In addition, inside this circle we have central angle AOB. This is central angle AOB, and this central angle AOB also subtends on the same chord called AB, exactly like this peripheral angle ACB. So those two angles are both subtend on the same chord called AB, and therefore the size of this central angle AOB will be twice as large as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, and therefore the size of this central angle AOB is also subtended on the same chord called AB will be equal to 2 theta. Okay, so we can actually implement all 13 in our drawing. Why? Because in our drawing we have those two angles, they are both subtend on the same chord called DB. And therefore, according to all 13, the size of this central angle DOB must be twice as large as this peripheral angle DAB. The size of this peripheral angle DAB is x over 2, and therefore the size of this central angle DOB that is also subtend on the same chord called DB must be equal to x over 2 times 2, that is x. Likewise, we defined the size of this central angle CDA is y over 2. Again, we define the size of this central angle CDA is y over 2. Then we join points O and C together by straight line, and join points O and A together by straight line. By doing this construction, we can do central angle COA. Central angle COA subtend on chord CA, exactly like this peripheral angle CDA that is also subtend on the same chord called CA. So those two angles, they are both subtend on the same chord called CA, and therefore, according to rule 13, the size of this central angle COA must be twice as large as the size of this peripheral angle CDA. The size of this peripheral angle CDA is 1 over 2, and therefore the size of this central angle COA that is also subtend on the same chord called CA will be equal to y over 2 times 2, that is y. Okay. In the next step, I copied the green triangle triangle DEA, this green triangle DEA in the new page, and we implemented all 4 in this triangle DEA. So actually, this is the green triangle DEA that I copied from the original drawing. So we have here, this is again EAD. The size of this angle EAD is x over 2, and the size of this angle EDA is y over 2. And we have also here angle AED. All those 3 angles, they are located inside triangle EDA, and therefore they are defined as the angles of this triangle EDA. while this is angle BED, that is located outside triangle EAD, and therefore it is defined as the exterior angle of this triangle BED. Angle BED is defined as the exterior angle of this triangle EAD. So in the next step, I actually presented to you rule 4, and we implemented rule 4 in our drawing. So according to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles A, B and C. And because of the fact that they are located inside this triangle, all those three angles are defined as the interior angles of this triangle, while this is angle E, it is located outside this triangle, and therefore this angle E is defined as the exterior angle of this triangle. According to this rule 4, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C that is definitely adjacent to angle E, and the two other angles that are not adjacent to this angle E are A and B. And according to this rule 4, the size of the exterior angle E is equal to A plus B, that is the sum of the two interior angles that are not adjacent to it. So again, according to this rule 4, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, the size of angle E is equal to A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have the exterior angle BED. Angle BED is the exterior angle of this triangle EAD. And according to rule 4, the size of the exterior angle BED, it is equal to the sum of the two interior angles that are not adjacent to it. This is angle AED, that is definitely adjacent to this angle BED. And the two other angles that are not adjacent to it are those two angles. And according to rule 4, the size of the exterior angle BED will be equal to x over 2 plus y over 2. Repeat again, according to rule 4, the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is equal to x over 2 plus y over 2. It is given us the equation that the size of the exterior angle BED is 45 degrees. Therefore, we substitute BED by 45 degrees and finally found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees, and it is equal to x over 2 times 2, that is x, plus y over 2 times 2, that is y. So we found out that x plus y equals to 90 degrees. We subtracted x from this equation and finally found out that y equals to 90 degrees minus x. Again, according to equation 1, y equals to 90 degrees minus x. In the next step, I repeated on the law of cosines and implemented the law of cosines on those two triangles, triangle DOB and triangle AOC. But before that, what is the definition of line segment OB? Line segment OB starts from point O, that is the center of the circle, and then from point B, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OB is the radius of this circle. We define the radius of this circle as R. Therefore, OB equals to R. Likewise, OD equals to R, OC equals to R, and OA also equals to R. All those four line segments are the radius of the circle that equals to R according to our definition. So in the next step, I copy triangle DOB in the page and implemented the law of cosines in this triangle DOB. So I'm please quickly on the law of cosines. The law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. The size of the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC. The size of this angle BAC is theta. So in this triangle ABC that could be any triangle, cosine theta equals to a square plus b square minus c square over 2 times a times b. Again, cosine theta, this triangle ABC equals to a square plus b square minus c square over 2 times a times b. So we can actually implement the law of cosines in that triangle, and especially we can implement the law of cosines in this triangle, DOB. So copy this triangle DOB in a new page and implement the law of cosines in this triangle, DOB. So actually, this is triangle DOB that I copied from the original drawing. This triangle DOB, DO equals to BO equals to R, it is the radius of the circle. Side DB equals to 2 units in its length, according to what is asked in the question. And we have here angle DOB is equals to X, according to Rule 13. So in this triangle, DOB, according to the law of cosines, cosine X equals to OD square. OD is R, therefore OD square is R square. Plus OB square. OB is also R, therefore OB square is R square. Minus DB square. DB is 2, therefore DB square is 2 squared, that is 4. So in total, in the amount of this expression, we have R square plus R square minus 4 over 2 times OD, that is R, times OB, that is also R. So in total, the amount of this expression, and we have 2 times R times R. So actually found out that according to equation 1, cosine X equals to R square plus R square, that is 2R square, minus 4 over 2R square. So cosine X equals to 2R square over 2R square is 1. And we have here minus 4 over 2R square. Here we divided both the numerator and the denominator of this expression by 2. And found out that cosine X equals to 1. And here we have minus 4 over 2 is minus 2. And 2R square over 2 is R square. So in total, we shall find out that according to equation 1, cosine X equals to 1 minus 2 over R square. Then I copied triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So okay, this is triangle AOC that I copied from the original drawing. OA equals to OC equals to R. They are both parallel of the circle, and therefore each of them is equals to R. Side AC equals to the square root of 2 units, according to what is given in the question. So according to the law of cosines, in this triangle AOC, cosine Y equals to OA square. OA is R, therefore OA square is R square, plus OC square. OC is also R, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2, so it is minus 2. So in total, the numerator of this expression, we have R square plus R square minus 2 divided by 2 times OA, that is R, times OC, that is also R. So it is 2 times R times R. So in conclusion, we found out that according to the law of cosines in this triangle AOC, cosine Y equals to R square plus R square minus 2 over 2 times R times R. R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2R square minus 2 divided by 2 times R, that is 2R square. Here 2R square over 2R square is 1, and then also minus 2 over 2R square. So in conclusion, actually, found out that cosine Y equals to 1 minus 2 over 2R square. Here we divided both the numerator and the denominator of this expression by 2, and so we found out that minus 2 over 2 is minus 1, and 2R square over 2 is R square. So we found out in total that cosine Y equals to 1 minus 1 over R square. This is according to equation 2. And in the beginning of the lecture, we already found out that Y equals to 90 degrees minus X. Y equals to 90 degrees minus X. Now we can substitute this equation 2 by 90 degrees minus X. We did it. And we found out here that cosine Y and Y is 90 degrees minus X, so is equals to 1 minus 1 over R square. This is according to equation 2. And we have the trigonometric identity. It's says that sinus x equals to cosine 90 degrees minus x. Therefore, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We did it, and we should found out that sinus x equals to 1 minus 1 over r square. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r square. So we have the values of sinus x and cosine x in terms of r. And in the next step, use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. According to equation 2, sinus x equals to 1 minus 1 over r square. If sinus x equals to 1 minus 1 over r square, it means that sinus square x will be equal to 1 minus 1 over r square squared plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r square. If cosine x equals to 1 minus 2 r square, it means that cosine square x will be equal to 1 minus 2 r square squared, and is equals to 1. We define t as 1 over r square. Again, t equals to 1 over r square according to our definition. So now we can substitute 1 over r square in this equation 3 by t. We did it, and we found out here that 1 minus 1 over r square and 1 over r square is t. So in total, this expression will be equal to 1 minus t squared. And we have also here plus 1 minus 2 over r square. We multiply this expression by 1. So in total, this expression equals to 1. And we have also minus 2 times r, 1 over r square. 1 over r square is t. So in total, this expression will be equal to 1 minus 2t squared. You can see 1 minus 2t squared, and it is equals to 1. So in conclusion, according to equation 3, we should find out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets on this side of this equation, equation 3, and finally found out that according to this equation, equation 3, 1 minus t squared is equals to 1 squared, that is 1, plus t squared minus 2 times t, and we have also here plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t, that is minus 4t, equals to 1. So here we have 1 on both sides of this equation 3, so 1 we get cancelled. After we cancel 1, in the side of the equation we left only with t squared plus 4t squared, it is 5t squared. And we also minus 2t minus 4t is minus 6t, plus 1 equals to 0. Okay, again, if we found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we'll find out the value of the values of t, because x equals to t. We did it, and here we have x equals to t, so we substitute x by t, and finally found out that is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have only 36 minus 20 divided by 2a. a is 5, so 2 times a is 2 times 5, that is 10. So we should have found out that t equals to 6 plus minus. Inside the root we have 36 minus 20, that is 16. divided by 10. The square root of 16 is 4. So in total we shall find out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So the first solution for t is that t equals to 1 from one side, but from the other side, according to our definition, t is also equals to 1 over r square. So now we can substitute t in this equation by 1 over r square. We did it, and we found out that 1 over r square equals to 1. Here we multiply this equation by r square, and finally found out that r square equals to 1. Here we took out of this equation, and actually found out that the radius r is equals to the square root of 1, that is 1. So actually found out that the radius r of this circle equals to 1 unit. But it is actually impossible that the radius r is equals to 1. Why? Because of the fact that we have a code dB, the uniform code dB is 2 units according to what is given as the question. Again, code dB equals to 2. And it is very easy to see from the drawing that code dB is definitely not the diameter of the circle. Again, code dB is not the diameter of the circle. So here, code dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course equals to 2r. So the diameter of our circle 2r must be greater than dB, that is not the diameter. And dB equals to 2. And from this equation 2r is greater then dB is equals to 2, we derive that 2r is greater than 2. 2r is greater than 2. Here we divided this inequality by 2, and finally found out that the radius r for a circle is greater than 1. So the radius r of the circle is greater than 1. If the radius r is greater than 1, the radius r cannot be equal to 1. Okay, if the radius r is greater than 1, the radius r cannot be equal to 1. So we cancel this solution, and we take into account only the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So the second solution for t is that t equals to 1/5. From one side, but from the other side, according to our definition, t is also equals to 1 over r squared. Therefore, we can substitute t here in this equation by 1 over r squared. We did it, and we found out that 1 over r squared equals to 1/5. Here we could multiply this equation, and finally found out that r squared equals to 5. Here we took a root out of this equation, and finally found out that the radius r of this circle, that is the radius that we are looking for in this question, is either equals to the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. Okay, thank you very much.